What if you could help others to find the power to heal themselves? Physically, emotionally, and spiritually.
When I started teaching my classes, it was in 2002, and I was just doing the past life regressions and contacting the subconscious part. But then as the time went on and we found how powerful this was and what we could do with it, a lot of the students began saying, you know, advanced past life regression doesn't really tell what it's all about. This is so much more than that. We think you should change the name. So it was a few years ago we decided to change the name to Quantum Healing Hypnosis Technique. And this is the healing technique that we've now been teaching it, well, since 2002, that's 12 years.
What if you could time travel with them? Visit mythical places or angelic realms, other worlds, other galaxies. Help others to speak to their higher selves. You can. Dolores has taught thousands of people from across the world how to use QHHT, and now you can learn her method by going directly to dolorescannon.com. And don't forget to mention the discount code MORETALKS.
Established over 100 years ago, Watkins Books is one of the world's oldest and leading independent bookshops specializing in esoterica. We have the widest selection of esoteric books in the UK, and our friendly and knowledgeable staff are here to assist you in a unique ambience of our shop. So come and visit us in the heart of London as we're open every day.
The comments and views expressed on The More Show are those of the people that make them and do not necessarily reflect the view of Kevin Moore, The More Show, or this radio station and its affiliate or sponsors. This show is for entertainment purposes only.
Broadcasting from the UK and across the world online. You're now watching the UK's only alternative late night talk show, and I'm your host, Kevin Moore. For the next hour, I'll be covering subjects that will open up your mind and provide you with information you may have never heard before. On today's show, I'm about to be joined with Wallace Thornhill. Now, Wallace is an Australian physicist. He is a lifelong investigator of the electric universe, which offers a revolutionary view of our solar system's history and the nature of the sun, the behavior of comets, and stellar and galactic evolution. He is the co-author with David Talbott of the classic book Thunderbolts of the Gods and the Electric Universe. Wallace Thornhill, welcome to the show.
Thank you, Kevin. It's a pleasure.
The pleasure's mine. It really is. This is I was saying this off air actually. There's a lot of science in what you do. Obviously, you're a physicist. And a lot of what I do as well, you know, is sort of delving into consciousness and looking at all sorts of other phenomena, you know, whether it's law of attraction or ufology or whatever it may be. And so I've had to delve a little bit deeper into this, and I don't want to lose people too much with, you know, that may be new to this. So before we get into the really difficult stuff, we'll sort of, you know, go over what your work is and what the impacts are on mankind in a bigger sense, or our understanding of what we know about the universe. And just to begin with as well,
Sure.
You're based in Australia?
That's right.
Yeah.
I'm in Canberra.
Right. Where's that, near Sydney? Is that close near there, or is that some far time?
It's about 300 kilometres from Sydney, about a 3-hour drive.
Right, about a 3-hour drive, yeah. Well, it's like when people say to me, are you near London? No, Cleethorpes, which is about the same distance.
Well, actually, England is like a second home for me because I worked for 5 years in London.
Oh, right. You know, that's the first time I saw you give a presentation was at the Weird conference back in
That's right.
2011.
Yes, 2010.
2010. Oh my gosh. Well, that's about six years ago. Wow. How time? So you remember that conference?
Oh, I certainly do. That was my first visit to some crop circles.
Okay, right. Well, I thought your talk there was fascinating, and there's many YouTube videos of you giving presentations. When I saw you, I thought, one day I'm going to interview this guy. Here we are. So,
Yes.
excellent. Okay, well, just before you got into this work as well, what is your previous life to this current work that you're doing?
Well, you could say that this has been my life because I was interested in astronomy when I was a young kid. And one of my schoolmates who got in touch with me after 50 years or so of being incommunicado said that he remembers me as the kid who asked, "Do you think Einstein can be right?" So it seems I was born to do what I'm doing. And when I got to high school, I was lucky enough to be handed a copy of Velikovsky's Worlds in Collision, which is a famous book because it was a bestseller for many weeks or even months, I think, in 1950, and yet it ended up in a modern book burning because the scientists, particularly the Harvard mafia, they call them, decided they just couldn't stomach it. In fact, they didn't bother to read it. It was just the very idea that planets could have been moving around in the solar system within the memory of mankind was something that they just could not stomach. It had nothing to do with science. It was all about beliefs and the knee-jerk reaction of people who are confronted with an idea that is completely, out of left field. Anyway, that meant that when I went to university, I'd already been primed. I was questioning everything that I was being taught. And I asked questions, and I found that instead of getting good answers or even saying I don't know, I was getting hostility quite often, either that or an answer to something I didn't ask, something they could answer. So I got as far as doing or beginning a research year, postgrad, in upper atmosphere research, which is the closest I could get to astronomy at that stage. But then I realized that, for a heretic like me, there was no future in academia. They'd just crucify you. So I got out and joined IBM, went into computing. I enjoyed that because it was logical and, I loved in those days, the pioneering days, which was back in the 60s, the ability to learn everything about computers, the hardware, the software, the operating systems, the compilers. I knew the lot. So I was in some demand for fixing difficult problems. But after a few years at that, and I was promised, of course, overseas trips. And what I wanted to do was meet some of these people who'd put forward these crazy ideas. So I joined the Australian government, the Foreign Affairs Department, which gave me plenty of travel. And that was when I got to meet Velikovsky himself in 1979. And by that stage, the thing he did was to throw down a gauntlet to astronomers. And he said that electromagnetism played a role in the solar system, particularly during times when there was chaos. And that the ancients witnessed these thunderbolts of the gods and were frightened out of their wits by them, but also were in awe of the spectacle. The spectacle must have been, I can hardly imagine what it would have been like. But also, it was devastating. It was, this was where the idea of doomsday came from, and we've never got over that. I don't know whether you've noticed, but we always have a doomsday scenario put forward. It's either comets going to hit us, asteroids, or we're all going to burn up, or we're going to have an ice age. We haven't got over that trauma. And so this is one of the aspects, the cultural aspects, that the electric universe introduces that modern cosmology has nothing to say about. And this is why I think it's important that people get to know, even if they're not interested in the science, get to know what the implications are. And the implications are profound.
Well, that sort of leads in, doesn't it, to what is the electric universe, and also why do you do what you do as well? What inspires you to keep going in this work? What is it? What answers are you looking for that could be so profound that it would shake up humanity's understanding of the nature of reality, in a sense?
Well, over the decades, most of the time I spent trying to unlearn stuff that I'd been taught. And that's the most difficult thing. You know, it's easy to accept facts and just store them away and say, yeah, I got that. This is what you do now in school, in exams, and the ones who've got the best memories usually do the best. But that's got nothing to do with science. Science is about questioning, comparing ideas, not just following blindly one idea. And that's the problem with science and the teaching these days. It's just a single story, whereas there is another story. One of the things that kept me going was both wanting to understand how the universe works, and the other one was, before Velikovsky died, one of his last books was called Mankind in Amnesia, and in that he detailed his concern that man, or the whole of humanity, has suffered a trauma which was so dreadful, that is the doomsday trauma, that we act like insane people. He said as a psychiatrist, he was a trained psychiatrist, a medical doctor, and really a polymath. He said that from his training, you could almost treat the human race as you would an individual, and that is, you have to try and let them come to understand what it is that they've forgotten, but they keep trying to repeat in some way. You know, it's like your subconscious drives you to either revisit the trauma, and of course, in the case of doomsday, that means be totally destructive. You know, we've just come through 2 world wars at that stage, and the destruction was just absolutely mindless. It was insane, and that he thought was a manifestation of our what would you call it, psychosis. And he said the only way to get out of that is to understand what it was, why you feel the way you do, and gradually you come to terms with it. And he thought that unless the human race does that, we now have the destructive capability with nuclear weapons and that to actually revisit the doomsday of the gods on ourselves. And not only that, our mindless destruction of the planet at the present has to stop. You know, we have to realise that we're a part of this earth. We're an organic part of the earth itself.
That's right.
And if we keep treating it like a garbage dump and just producing rubbish in great amounts, which we do now, then our future is limited. So these are the main reasons why I do what I do.
Okay, and just very briefly then, what is the electric universe as well, as far as you understand it right now?
Okay, and I think I understand it better now than I did just a couple of years ago. But the fundamental aspect of it is that modern man knows that electricity is at the heart of everything. You know, we rely on it nowadays for heating, lighting, locomotion. You know, even our cars will be electric before long. And yet, when you look at astronomy, there's not a mention of electricity. You won't find any reference in the index, and you won't find any reference anywhere in the book about electricity in space. In fact, one expert, when we confronted him with these ideas, said, of course there's electricity in space, but it doesn't do anything. Well, that's absolute rubbish, because the electric force is 1 followed by 40 zeros times more powerful than gravity. And yet astronomers rely on this absolutely piddling force of gravity to describe the universe. And this gets down to a repeated pattern with human behavior, and that is that we tend to view everything from an Earth point of view. It's a geocentric, they call it, point of view. We've been through this over thousands of years, and we keep doing it. So we project what we measure on Earth, and we just say, okay, well, this is down to the mathematicians, who aren't scientists, by the way, they're just mathematicians. And you give them a formula and they'll apply it willy-nilly without necessarily thinking too deeply about it, because it allows them to make all sorts of weird and wonderful statements and predictions, generally which are never satisfied. But anyway, having this weak gravitational force that we experience on Earth is sufficient, of course, for us to exist on this Earth. The 6 sextillion tons of the Earth, we can still jump off it, so it's a very weak force. And a little magnet, can lift things away from the Earth. So this gives you some impression of the difference. Now, if you then extrapolate that out through the universe, then you can make all sorts of statements about what the sun's made out of and what the planets are made out of and how galaxies should work. But hey presto, what happened? As soon as they discovered how galaxies rotate, it doesn't work. In other words, the gravity we experience on Earth, you cannot extrapolate it out through the universe. It's not, this geocentric point of view is wrong. In fact, galaxies work like electric motors. The simple Faraday motor that Michael Faraday invented operates in exactly the same way. It rotates more like a rigid plate than something that's got slow-moving outer planets or stars and fast-moving inner ones. So the evidence is staring us in the face. The other aspect of it is, and this is the one that really either confronts or inspires people when they hear it, the sun is not what we're told. It was invented, the story of the sun, back in the horse and buggy, the gaslight era. And nuclear energy had only just been discovered. Now, of course, right through millennia, the story about the sun is that it's a kind of campfire in the sky. Well, now the scientists had nuclear energy, so it's a nuclear campfire in the sky. But not one single aspect of the sun that we observe is predictable from that simple model. In fact, Eddington was responsible for it, and he was an arrogant so-and-so. He said it should not be too difficult to explain something as simple as the sun. Well, that's okay, provided you don't actually think too much about what you actually see. The sun is driven by the galaxy. The galaxies are electric, so if they're an electric motor, there's electric power coming through. And the power is not visible. We don't see wires strung up in space. But plasma itself is a very good conductor. It's better than copper, but it's limited in the current that it can pass from one place to another. And it operates in what they call dark mode. So the stars are strung like streetlights along the power lines within a galaxy, where the current flows in along the spiral arms to the center and then jets out along the axis. Now, all of this can be shown by radio astronomy, and which can measure the magnetic fields that the power generates and so on. And radio astronomers are the best placed people to actually prove this. And one radio astronomer has done this very successfully, but of course nobody wants to know, because this just destroys the present story. So
absolutely. So well, where is the electric force coming from of the universe? What's creating that?
Well, this is when you get back to having a little bit of humility about how much we can actually know at this stage. And there is an astronomer who lost his telescope time when he proved that the Big Bang didn't happen. This is this kind of thing that happens when you find something that goes against the beliefs. And science, particularly cosmology, is based on beliefs. His work, he was an observational astronomer, so he had the pictures on his walls that he would stare at day after day. And he finally realized that, and he actually produced an atlas of peculiar galaxies, so he knew what he was talking about. And he said, it seems from the material that he's got that the redshift is not a measure of the speed of something moving away, which is where the Big Bang idea came from. It's actually a measure of the youthfulness of an object. When an object is first born, it's faint and it is highly redshifted, which is saying something about what's going on inside those bodies. It's got nothing to do with how fast it's moving away. So that destroys the Big Bang. And he said, based on that the universe is of unknown age and of unknown extent. So we cannot say, if there wasn't any Big Bang, we have no idea how the universe is created, because that first requires that we understand what matter is, and we don't even have an answer for that.
No.
So it paints a different picture. But the electric universe in particular, instead of, I don't know whether you've watched these programs by Brian Cox and other showbiz personalities like that, they talk about the vastness of space and how we're isolated on this tiny rock orbiting an insignificant star in an insignificant galaxy amongst billions of others, and it makes you feel hopeless, disconnected. We're not a part of the universe, we're isolated. The electric universe says no, the electric force actually operates at phenomenal speed, so that we are in contact with the rest of the galaxy, for instance, practically in real time, which for those people who are interested in communicating with extraterrestrials means that no extraterrestrial with any brains would use radio to communicate, because it's too slow. It's far too slow. It takes 4.5 years to say hello to the nearest star, and then 4.5 years to get a reply. Well, that's crazy. But the speed of thought, spans the galaxy almost in real time. And this gets down to consciousness and, being a part of a conscious universe.
Isn't it incredible when transmission was, by radio waves was discovered, and just prior to the discovery, the scientists of the day would have thought that that kind of talk was crazy. That there's something in between this invisible spectrum that we can't see that's able to conduct and to transmit. And now look what we do with that. When you imagine the amount of transmissions going through us, right, even where you are and where I am right now.
That's right.
Various different frequencies from TV, radio, CB, Bluetooth, the whole gamut, and I have no sense that is there. Do you know what I mean? Unless I'm tuned
that's
into
right.
it. And that's incredible what you just said there about maybe that the process of channeling, in a sense, could use the electric universe as we don't understand it right now to
yes, exactly.
to transmit that kind of reception and those kind of that understanding, in a sense. That's a big aha moment to me, that is. And you imagine races out there that are even 100 years ahead of us, let alone 1,000, and they understand the nature of reality better than we do. And
yes.
and when
we're babes in arms.
Absolutely. And when you said before that what inspired you, one thing is the nature of the universe and our galaxy. Well, that's always inspired me as well. When I look up at the sky and I think, we're one planet, possibly out of 1 trillion planets just in our galaxy, possibly with more unfathomableness out there, in the sense that there may be 100 billion other galaxies or more in the unknown universe, or the known universe.
That's right.
Does it end? Is there an end to it? They call it infinitive, don't they?
Yes, that's right. Which is a meaningless term. It just means it's beyond anything that we can conceive. I could possibly give you a simple idea of the difference between a radio wave and the speed of thought.
Please.
It's like having a taut rope, and you pull on one end, the other end feels it almost instantly. That's the speed of thought. But if you send a radio wave, you wave the rope up and down, and it takes time for that wave or ripple to get to the other end. And that's the difference. Because all light is a disturbance in a medium. And unfortunately, science got rid of the medium and then couldn't explain how you go from A to B without inventing a particle. And so modern science is a real mess, both at the particle level and at the galactic and the interstellar level. But once you begin to understand these things more clearly, it opens up some chance for those people who, I think I said at the Weird conference, if you want to understand UFOs and extraterrestrial intelligence, the first thing is to fix up our science so that it bears some resemblance to what's out there. And that's really what I'm about.
And then you think of the nature of reality in the sense that what if there's multiverses? What if there is parallel universes? Are they connectable, do you think?
Well, no, this is where the mathematicians have taken over science, and they should be put back in the back room and handed back to the Faradays and the experimenters and the natural philosophers. They're the ones who ask the question, what do you mean by mass? What do you mean by energy? Do you know there's not a sensible definition of either of those things? And yet we all know E equals mc squared, but not one scientist on Earth can explain to you what that means in real terms. So we just assume that they know what they're talking about, but they don't. They're mathematicians. The real scientists are the people who ask that question and want to know, because otherwise, you can perform mathematical operations, even if you can do it in your sleep. Doesn't mean you're a scientist. They keep saying mathematics is the language of science. No, it's not. And it's only the language of science when you can explain exactly what each of those symbols on the board means in physical terms, real physical terms, 3 dimensions, and so on. And time is not malleable. You can't fiddle with it. They keep making things real that aren't real. And time is a concept that's got nothing to do with past and future and all that nonsense. So there are no multiverses. The definition of the universe is everything there is, which would include other universes if there was such a thing.
Well, what you're saying, what you're saying there is we're already in the everything. So if there are other universes, yes, we're already part of that.
That's right. It's all part of one thing. So even if there were alternative ways of building a universe, then it must be part of what we're a part of.
Well, that's wow, my head's just spinning here, and I know I want to get into some of the deeper stuff as well. And we've barely scratched the surface. I studied electronics. That was my previous life in a sense, and I always remember looking at the textbooks, and then looking at the atoms and the way that the atoms were made, and I always thought, well, how could you prove that that's what an atom behaves or looks like? We can't go down to that structure. We've never seen it, but yet the textbook tells me that there's an atom and there's the electrons around it, and due to the side effects of results of experiments, then that's how they predict that the atom must behave and look. But we don't. As a physicist, could you even answer that? Is our understanding of the atom even right?
If you followed the rules of classical physics, which was an attempt to simplify things, rather than the present day thing where you try and invent more particles and more forces and try and get a Nobel Prize for the effort, the electric universe goes to the absolute extreme and says there is only one force in the universe, the electric one, and it is virtually instantaneous. And you can, the other thing is that you see in nature repeated patterns. So the atomic model with orbiting electrons around a positively charged nucleus works very well. And in fact, I think we can be pretty sure that that's the way it operates. What the electric universe does is to go one step further and say the particles themselves, the electrons and the protons, are made up of smaller charged particles doing exactly the same thing. When you do that, would you believe you can explain magnetism and gravity without any other messing about? They're just forms of the electric force. But the mind-bending thing is that magnetism and gravity are very similar, and that is gravity must have a dipole. In other words, there is a repelling, if you put two like gravitational poles together, they will tend to repel one another. We just happen to sit on the outer edge of one pole of a magnet. So we're like iron filings. We get attracted to it. But another body like the sun or another planet will also have the same pole facing outwards. So would you believe that gravity is actually repulsive between celestial objects? So any idea of asteroids crashing into the Earth and that is absolute nonsense. What you'll get is electrical discharges, and you'll get an attempt to avoid each other.
Okay. Do you think light plays any part in this as well?
Yeah, light is not understood either, because Einstein did away with the medium through which it must move. You cannot pass light through nothing. It must have a medium. And in fact, we know the vacuum has the characteristics of a dielectric. You know, it has dielectric constants, which means there is matter there. You can't have dielectric constants with nothing there. It's got to have something there. So the electric universe says the universe is full. It's full of neutrinos. Neutrinos are matter that can pass through us as if we're not here. So it's a medium that's available for light and radio waves and so on to travel through what appears to be a vacuum. Just because we pump all the atoms out doesn't mean it's empty. And that has significant implications for these gravitational wave detectors, because they pump everything out and say, we've got the biggest vacuum chambers in the world. Yeah, so what? They're full of neutrinos. So if a disturbance comes through those neutrinos, you're going to get a signal, and you'll interpret it as a black hole somewhere out in space, when there's no such thing as a black hole.
Right, and we'll get into that just very quickly as well, and just very briefly as well. I say briefly, these are questions that man's pondered for a long time. And okay, with your model then, have you considered, well, what was there before the universe, or is that kind of question unanswerable? Because what is infinitiveness, if there is such a thing, and what is nothingness? What does nothingness look like, and what came from that? What produced that from that nothingness?
Yeah. What we have to do is to say our present state of knowledge and investigation doesn't allow us to say anything about the creation of the universe or its extent. All we can do is deal with what we can see. And that's fine. This is good, because that means that when you present this stuff to kids in school, they'll say, oh, I'd like to find out what it is. And that will give them a life's purpose. And giving kids a life purpose is something that we seem to be failing to do these days.
Yeah, that's so true. So yeah, it's unanswerable. I mean, I consider it sometimes, but then my tiny brain can't consider nothingness. It can't consider, well, if there's nothing, what is nothing? Is it no light? Is there no absence of darkness? Is there no color to it? Is there just nothing? No coldness, no hot. It's. But then you could. It's almost like trying to ask, okay, where people have near-death experiences, and then they go to this other realm, this place where consciousness exists. If that's what we are, consciousness, it's almost, there are no answers to what that is as well, except there may be something beyond this, and maybe there was something before the universe that's created this as some sort of way to have experience. I don't know.
Yeah, well,
it's unanswerable.
I think the electric universe offers a simple answer to what is consciousness, and that is that it is the interaction of the information that's stored in the universe. Now, when I said that atoms and so on are made up of smaller systems of orbiting charged particles and so on, all of them behave like little tuning forks, if you like. And of course, if you have enough of them, all resonating, making a sound, then it's like having a whole symphony played at once. Now, the neutrinos themselves must be built the same way as the other particles, and so they must act like little tuning forks, and they can hold information. So the universe is full of information. It's full of matter. It's a repository for everything that we learn. And this gets down to the work of Rupert Sheldrake, whom I'm sure you've heard of, with his morphic field. Now, a field is a description. It's not an explanation. And I think the electric universe gives a model which could provide an explanation for the morphic field. and also for consciousness and so on. And it also gives a model which could be tested, I think, eventually, for remote viewing, all of these strange ESP-type activities, actually has a physical, scientific model which could be tested. And this is essential if you're going to do real science.
Incredible, incredible. Okay, thank you for that. Yeah, because with the remote viewing, there is a hell of a lot of accuracy in that, and of course the U.S. government had their black projects using them as well. Maybe other governments did as well. So, in the sense of, okay, let's just get back to gravity then, because that's a fascinating thing. Now, when I watch Brian Cox, I did watch him a few weeks ago actually, and he had been sent a question about, why are planets in a sphere shape, and what causes that? And his answer was, well, in the end, it was down to gravity. Gravity is what's causing it to be round. But with your work, obviously, gravity doesn't play as big a role in the formation of these planets, do they? I mean, for example, planet Earth.
That's quite right. Yes, the story of the formation of the solar system is a once upon a time fairy story. It was made up centuries ago, and no one has had a better idea. Simply because with gravity, all you've got are explosions and collisions. So that was why they came up with this idea that you could form planets out of a ring of dust and gas. There is no evidence at all that this is possible. In fact, everything works against it, because up to a certain size, when you get collisions, they just fragment these bodies, and so you still have a ring of dust and gas. The answer is actually quite simple, but it's quite different to anything that you've heard before. And the answer comes from the plasma scientists, the guys who actually work with electric currents through a very low pressure gas like in space. And they've shown that, in fact, they predicted that you would find stars formed like beads in bead lightning along the lightning channel in a cloud. And lo and behold, when they put up the Herschel infrared telescope, which could peer into these clouds, what did they see? I think the headline said, "The stars appear like beads on a necklace." And this is quite right. This is exactly what the plasma cosmologists had predicted. Of course, the gravitational cosmologists had no idea. They don't pay any attention to the plasma guys because it's too difficult. But the other aspect, the electric universe says not only are stars formed along those lightning channels, but also bodies of all sizes, including planets. And what happens in the laboratory when these plasma experimenters try this out is that the stars, or their what they call plasmoids, scatter like buckshot, was the actual words used. And what do you, just a month, I think within the last month, there was a report saying we've measured the velocity of these stars along these filaments in these clouds, and they're all scattering left and right. And this is what the plasma cosmologists predicted. What happens then is you've got all of these bright bodies, the stars, but you've also got all these planet-sized objects. And what happens is that with the electrical model of gravity, capture is quite, actually it's expected, because what happens is two bodies come close to one another and one starts to discharge, and that discharge changes its gravity, its mass, and the result is capture. So the solar system is a blended family. All of those bodies being a long way from the sun must have been captured. And of course, the outer bodies have got their own little solar systems. So they would have captured some of those. But one of the other things that can happen in that lightning bolt in the molecular cloud in deep space is that the star finds itself, once it's been born, in a situation where it's electrically unstable. And what happens? It fissions, it splits into two. And so you'll get a so-called hot Jupiter orbiting very close to the body. And this is what's been found. There's thousands of them out there now, they've discovered. And the problem for the astronomers was, well, these bodies can't form that close to a star. They should be blown away by the star's wind, if you like. But here they are, some of them orbiting in days or even hours around their central star. The electric universe and the plasma cosmology explains all of this very simply. But it requires electricity in space.
That's it, isn't it? And okay, so for example, then we mentioned gravity on Earth previously, and so rather than the dinosaurs, as you've said before in past interviews, being killed off by a meteorite or some sort of cataclysmic incident that was global, how that would occur, I'm not too sure. But you think the gravity of the planet changed?
Oh, it must have. The evidence is there that those animals could not have stood up in present-day gravity. They would have, if they were muscular enough to do it, they would have broken every bone in their body simply because of their colossal weight. And some of those animals had necks which are so long that even if you built one of them with the same weight using steel beams, those steel beams would sag under the weight. So it's just insane to suggest that they were, galloping around the countryside, fleet-footed, in present-day gravity. The same goes for some of those birds, which are as big as small aircraft. They couldn't have flapped their wings without breaking them.
Well, that's very true. So what caused the gravity change, do you think? What was occurring in our system at the time?
Well, gravity is the result of the distortion of little systems of positive and negative charge within subatomic particles. And when you distort them, they form little electric dipoles. Now, if you dump charge or remove charge from a planet, you are changing the electrical stress within it, and you will change its apparent mass and gravity. And that's what happened. I mean, the ancients said these thunderbolts struck the Earth and gouged the Grand Canyon, or did a lot of other destructive things. I mean, I've travelled through the southwest of the United States, and that landscape has just been ripped apart electrically. You can just, the evidence is just staring us in the face when we understand it.
Very, very interesting. Okay. And you mentioned black holes previously as well, that our understanding of the, the sort of mass at the center of the black hole, in a sense, I guess that's what you're saying, is not as it seems to be.
No, you can't generate supercondensed objects anyway, because you've got a repulsive gravitational force inside the objects which will prevent it. But mathematically, it's nonsense too, because Newton's law of gravity, it works fine when you have more than one body in the universe, because you can superimpose those bodies mathematically and it works. But a black hole exists in a asymptotically flat universe. You've seen those rubber sheets which are distorted by gravity, I might add. The space around them, according to that nonsense, is curved, and it's curved asymptotically, which means that you cannot superimpose two objects in that universe. Doesn't work mathematically, doesn't work physically. So this idea of colliding or coalescing black holes is sheer nonsense. You cannot have an observer, you cannot have any other body in that universe occupied by that black hole. So even the mathematics is misleading.
So okay, if I might have missed something there, what do you think the black hole is then?
Yes, well, you've got the problem then. You've got to answer what's going on in the centers of these galaxies. And the simple answer is, it's been answered by the plasma cosmologists, when you have current flowing into the center of an object like that, it forms what's called a plasmoid, which is a donut-shaped, very compact set of filamentary currents. And in the laboratory, what happens is, as this little thing twists and tightens itself up, it gets to a point where down the center of the donut, the particles start to collide. And when they do that, you get these beams of neutrons coming out along the axis, and also radiation and all sorts of other stuff. Now, neutrons decay into protons and electrons, which becomes hydrogen. And this is what we observe in the centers of galaxies. Occasionally, a galaxy will go active and it'll spurt this material out of the center. So what you've got in fact is what we can observe and test in the laboratory. It's a plasmoid. You don't need, when you're talking about electromagnetic forces too, they're so much more powerful than gravity that of course it looks like you've got millions or billions of stars packed into that region, because E equals mc squared. If you've got a lot of energy, electromagnetic energy, stacked into that tiny little thing smaller than the solar system, then it will look as though it has the mass of millions or billions of stars, but it's not a black hole.
Right, okay, that's incredible. Okay, now obviously we have our International Space Station up there orbiting right now, and it uses solar panels to gather power to recharge the onboard batteries. We're obviously missing something, aren't we? That there's another way to tap into energy, and how would we do that?
Yes.
And was Tesla close to tapping into what we're talking about here today?
I don't think Tesla was. I mean, I consider him to have been one of these intuitive geniuses, rather like Velikovsky, who could see the answers and put ideas together, over a broad range of disciplines, if you like. And I think he could actually almost visualize circuits in his head. But the answer is, we're told that there's been countless billions of dollars spent trying to produce power like the sun. Well, the first thing to do is to understand the sun, and then you've got some chance. The electric universe says that a hot plasma, which is heated by electrical power, actually is the best place to produce nuclear energy. And we know the sun is producing nuclear energy because neutrino detectors have seen this haze coming from it. But it's just assumed it's coming from the core of the sun. It's not. It's coming from the surface right in front of our eyes. That's where all the nuclear reactions are taking place. And the heavy elements that it produces we see in the spectrum of the sun. So what we've got to do is harness the way that a star really works. And I should tell you that we're actually doing an experiment in Toronto right now. We're in phase 2. Phase 1 was very successful. We're doing phase 2. And we will be testing the way the sun or stars really work.
So there may be in the future a way to tap into this stream of energy.
Oh, sure. You realise that in hot plasma you can use catalysts like you do in chemistry, to make reactions work at much lower energies. And this is what I expect will happen. In fact, low-energy nuclear reactions are possible. Biological systems do it. Professor Louis Kervran, the Frenchman, did some amazing work showing that biological systems can tap into nuclear energy. Well, if enzymes, biological enzymes can do it, so can we. In fact, the Russians have just a few months ago announced that they have found out how to do it using a biochemical arrangement to transmute elements. And I believe that they're correct. Once you've learned how to do that, the world's your oyster, convert lead into gold.
Yeah, absolutely. And, if there are other civilizations out there, which I feel that there most definitely is, who knows what they've tapped into and what they've discovered as well.
Of course.
Yeah. And when we talk about, if there are, and when you look at some of these UFO videos, unexplainable, no understanding of what they are, in a sense, where they're these shining balls of plasma they look like sometimes. Is that
Yeah, that's right.
is that another life form?
Once you understand gravity too, you can realize that anti-gravity and cancellation of inertia is possible. But I like to think of our situation now like Arthur C. Clarke in Childhood's End. He required these highly sophisticated aliens to allow us to grow up. I suggest that the electric universe can do it. We can do it ourselves and achieve childhood's end in the universe.
I think there's some truth in that. I definitely do. And I know we've kind of touched on it a bit about, when we talk about, star birthing in a sense, but we could look at planet birthing just to go back there. Mm-hmm. Do you think there's something to do with the sort of planet coronal mass ejection and giving birth to planets that way, maybe, or?
Well, a star can split in two if its electrical environment, its stress is so great that it needs to increase its surface area. One way of doing that is to split part of itself out. And I think that results in some of those very close orbiting hot Jupiters. But life itself, the best place to find life is orbiting a brown dwarf. Now, astronomers have sort of half-heartedly come to that idea, but when you understand brown dwarfs and what stars really are, you realize it's even better than we thought, because a brown dwarf is not a dwarf at all. For instance, if Jupiter was to light up as a brown dwarf, the outer part of its magnetosphere, which is as big as the sun, would light up red, that it would glow red. Now, its innermost moons would be orbiting within that red glow. That is the perfect place for life to start, because it doesn't matter how your moon is spinning or not spinning and which way up it is and all this kind of thing. It will receive the same energy over every square inch of its body. And the evidence is that the Earth was in that situation before we joined the sun. So we are the aliens in this solar system. We weren't born here. And in fact, the trauma of being torn from our mother's womb, so to speak, is something that we have to understand and come to terms with, because I think we were traumatized by the whole process.
So okay, and what if our sun wasn't there before as it is now? What was at the center, in a sense? What was there?
What was there? Well, all of the bodies in the solar system have been captured. So the inner bodies, the Venus, Mercury, the Earth, and Mars, were associated with the captured bodies. And when you have a large body like, say, Jupiter, it's got a huge number of moons, and some of them, our moon looks like one of its moons, actually.
Yes, it does.
If you were to put our moon out there and put it into orbit around Jupiter, it would look just like the other ones. So it probably lost the moon when it came in. When Jupiter or Saturn or Neptune or Uranus, any of those bodies approach the sun, their gravitational sphere of influence gradually shrinks because the sun begins to dominate. As that shrinks, it loses its outer satellites. And of course now they're finding objects out beyond Pluto, which appear to be associated with Neptune. Well, this is to be expected.
Yeah. And so maybe the history of some of our planets in our solar system have a history that we do not or have not even comprehended, or it's beyond our understanding right now, in a sense. But the electric universe maybe gives us some clues to that.
Oh yes, it gives a lot of clues. In fact, it can tell you the last chapter of our existence and that of Mars and Venus. And we can understand why Mars looks like it does now with that huge gash across its face, because the ancients witnessed that. In fact, Mars was called Scarface by the North American Indians. And the Greek myths talk about being wounded in battle. And it also explains why Mars was the god of war, because that poor planet got tied up exchanging Thunderbolts, and it got destroyed. It really got destroyed. So if there was there probably was life on Mars. It had a very similar environment to the Earth's in those earlier times. So it is worth looking for life on Mars or any remnants of it. But it got absolutely hammered in that process of being torn from its parent.
Right. Now, thank you for that, by the way. Now, someone like Graham Hancock, he'll talk about a global amnesia that took place. That changed everything. That relics from a time forgotten are stood there now, and we don't even understand how they were constructed and built. But it was part of this mass amnesia when some catastrophe happened. Where would that fit into the electric universe then, in a sense? If there was any truth in what he was saying, that there was some sort of mass event that happened, and for example, maybe the name Atlantis, there was something there, but it was all wiped out.
Yeah, there's a lot of confusion caused by the artwork and the sculptures and the monumental masonry and all that kind of thing that was built following these disasters. Because what mankind was trying to do was recreate on Earth the realm of the gods. We wanted to return to the golden age, the time when one particular, our original sun, was our mainstay for our existence. And of course, we don't understand what the hell it is they're trying to show us with these images. And in fact, the most telling ones are the most ancient ones. They're the petroglyphs. And it was only when we got an expert in plasma physics, one of the guys who was a leading plasma cosmologist, who came to one of our meetings back in 2000. And he looked at what we were doing and he said, "Oh my God," he said, this has changed my life. He said, "What you've just shown me is classified information in our high energy lab experiments." And he realized then that he'd been wandering out hunting in near Los Alamos, walking past these Indian petroglyphs, and didn't realize that they were the same images that he was seeing in his high energy experiments. Once that penny dropped, he established a global network of people documenting these petroglyphs. So that was really where the reconstruction of the history of the Earth came together with the electric universe reconstruction of the science involved.
Yeah, absolutely. And, one question I was going to ask you previously as well, going back here a bit, but this will be interesting to our audience as well, in the sense that I think the electric universe also answers why probably SETI has not picked up any, intelligent signals as well in our universe.
That's right. Yes. As I said, the most hospitable place for life is orbiting within the red glow of a brown dwarf star. And, of course, that's a glowing plasma. And plasma, as I said, is a very good conductor of electricity, which means that you have, in effect, a very effective radio shield around you. And you would not know if somebody was broadcasting television programs of Brian Cox at you. Because, and also we wouldn't know there was anybody down inside that envelope who were able to communicate using radio. But, of course, that gravity cannot be shielded against. Well, gravity is the same force as the speed as thought, and so thought cannot be shielded. So any highly intelligent species living in such an environment, that is orbiting within the plasma sheath of a brown dwarf, would know that it's thought that can actually pass through that shield.
So my kind of final few questions here, and I know we're going a bit over time, and I really appreciate you staying with us, because I do. Thank you. What about
you can always edit out the uninteresting bits.
Well, that's it. Well, what about dark matter then? A lot of people you bang on about dark matter, and I think it's fascinating. But then, there is no dark matter in the electric universe. It's kind of answered in a sense what that
No,
could
there
be.
isn't. No, that's right. Dark matter's there because you need something to replace all of this electromagnetic energy that drives galaxies the way they do. So if you use gravity, you've got to put matter around. The funny thing is, of course, that they just put it wherever it's needed, willy-nilly, without having any restraints at all. Well, this is not the way to do science. If you're going to invent this stuff, you've got to be able to predict that this is where you will find it. But they are continually surprised by new discoveries about the motions of galaxies. It just doesn't work. You don't need it. The same with dark energy. Dark energy is a misinterpretation of supernovae. If you've got a highly redshifted object with supernovae going off in it, the energy of that object is less. That's why it's redshifted. And the supernova explosion is less energetic, and therefore it appears as though it's further away than you expect. It's got nothing to do with accelerated expansion of the universe. It's simply the energy of this newborn object is less.
Yeah, okay.
So all this darkness is dissipated.
Right. Okay. Yeah. Again, this is. I mean, your book was cutting. Well, I call it a bit of a classic now, really. I think you can still get it on Amazon. Are you planning on re-releasing it or?
No, I'd get it through Thunderbolts.info. Yeah, this is the book here.
There it is.
Yeah, Amazon really gouge book publishers. It's better to go to the people who actually produce the book and get it direct from them, and you'll get it through Thunderbolts.info.
Okay, well, we've been putting your website and the book up throughout this interview as well. I feel like we've just left so much out of this interview, and that there's some important things we've probably not touched on. Is there anything that you might like to mention as well?
Well, I think the message that Velikovsky had still stands, and that is that unless we understand ourselves and our real relationship and connectedness with the universe, we will not have a future on this planet. I think also that it has a big lesson for education, and that is that we have to stop treating kids as just receptacles for facts, because most of the facts are wrong anyway. What we should be doing is challenging kids in school with ideas which were argued over centuries, and even last century in particular, that were argued over. For instance, they should be shown the arguments against Einstein. There were some extremely good ones, and they should be asked to go away and think about it and come back and give their view on which is right. That way you inspire kids to think rather than just repeat, and also I think you will inspire them to do science again instead of turning away from it in droves as they are now.
And absolutely, and like you said as well, sometimes when you mix science with intuition, then you get a Tesla.
Ah, yes, that's right. I find that the way I do it is intuitive to a large degree. You have to let your mind be open to the information that's out there in the universe.
I've got to ask you this final question, right? I'm getting well into the law of attraction right now. I'm really, really starting to embrace it. Yeah, and it's
Yes.
it's working. Where does something like the law of attraction and the electric universe fit in? It's almost like, there's something you're tapping into with the law of attraction. That's this greater reality that's out there.
Yes, yeah, I agree. If you saw the people who have joined us, and at the times at which they do so, they are turning up just when they're needed to an incredible degree. And I think the idea is to hold the dream, whatever it is that you are here for, and I feel that everyone manifests with a purpose. You don't come as a blank slate. If you can find out what that is and then go for it, the universe will provide.
Would you say the electric universe would provide?
Of course, the universe is electric.
Yeah. No, I just got to put that in there because that's where, and so this so could you actually say then that this electric universe is aware of itself in some way?
Yes, I would call us the self-referential part of the universe, because the universe experiences and learns through us. Rupert Sheldrake's proven this, and it doesn't require that you be even a sentient being. It seems even if you produce a new chemical compound, for a while the compound doesn't know what its boiling point is or its physical characteristics are. It seems to learn it. The more you do it, the more the universe learns how to do that. And I think in our realm, the 50th monkey syndrome is what they talk about, where you teach enough mice or rats a trick, and you'll find that succeeding generations seem to pick it up almost instinctively.
I wonder what this electric universe is trying to do. I wonder what its purpose is, in a sense. Is it just to be? Is it just to experience? Is it, these are questions I know we can't answer in 2 minutes, right? But
that's right, yes.
It does make you think.
I think you need to realize that being conscious, you think, and you come up with a purpose. And if you focus on that purpose, then the universe gets involved in ways that you cannot fathom.
Right, so just keep it simple like that. I like simple, and there you go. Yeah. You can.
Me too.
Yeah. Well, you can tap into that, most definitely. Yeah. Well, look, I know we've left stuff out, but there'll be another time. I really appreciate you coming on, and I really appreciate you sharing this work, because it's not been an easy path for yourself to go down this road that you have. But thank God that you have, because someone's got to do it.
Yes, that's quite exhilarating. I call it an adventure, and I welcome anyone else to partake of that adventure.
Yeah, absolutely. Well, I'd just like to say, Wallace Thornhill, thank you so much for joining us today.
Thank you, Kevin. It's been a pleasure.
Well, we've come to an end on tonight's show. Don't forget that you can listen and watch all our past interviews on the More Show's official YouTube channel. Remember to subscribe to our YouTube channel for new daily shows. You may also find out more on all past and upcoming guests on the show via themoreshow.com, and do like us on Facebook and Twitter for the latest updates. So until next time, be safe.